Pick a city in the north and eastern hemisphere, and pick a city in the southern and western hemisphere. Then graph the hours of daylight for each and determine the important features. My northern city was Riga. My northern eastern city is Riga. Its summer solstice is June 21st, and it's 17.87 hours long. Its winter solstice is on December 21st, and it's 6.83 hours long. Its equinoxes are at March and September 21st, and they're both 12.35 hours long. I picked Montevideo for the southwestern city. Its summer solstice is on December 21st, and it's 12.93 hours. Its winter solstice is on June 21st, and it's 11.17 hours. Its spring and fall equinoxes are both 12.05 hours on March and September 21st, not respectively. The spring equinox is September 21st, the fall equinox is March. Looking at Riga, its period is going to be 12 months. Therefore, a number, when divided into 2 pi, should get 12. 2 pi divided by what equals 12. So it looks like what is going to be pi over 6, and that's going to be the number within the parentheses of the cosine. When looking at the solstices, 17.87 minus 6.83 is 11.04. 11.04 divided by 2 equals 5.52, which is the amplitude. Fred is at the middle of these values. We take the solstices, add them up, average them, that's 12.35, that's Fred, or the equinoxes. When we model the cosine function, where x is the number of months after December 21st, it bottoms out at the start, maxes out halfway through, and then bottoms out after one period. That's the same behavior as a negative cosine function, so we need to put a negative sign in front of the amplitude to reflect that. So this is our final function, amplitude, period stretching, and Fred. Looking at Uruguay, its period is also 12 months, so the number in the parentheses will also be pi over 6. Its amplitude is solstice minus solstice, long minus short solstice, then halve that, and that's 0.88. Fred is the average of the two solstices, which is 12.05, which is the equinoxes. When modeling the cosine function, where x is the number of months after that, it does the opposite at Riga. It maxes out at the start, bottoms out halfway through, and hits a maximum again after one period, which is the same behavior as a standard cosine function. So therefore, there's no need for the negative sign in front of the amplitude. This will be the final function. Note, amplitude, period stretching, Fred. The special features of each function. Riga, which as you recall the function was this, has a maximum of 17.87, a minimum of 6.83, a Fred of 12.35, an amplitude of 5.52, and a period of 12. Montevideo, which has this function, has an amplitude of 0.88 reflected here, a period of 12. It got stretched by this. This acts as the stretching, and a Fred of 12.05, and a minimum of 11.17, and a maximum of 12.93.